everyone, welcome back to my channel. In today's video, we'll see how to implement a role-based access control with Google Kubernetes Engine. In this lab, we'll be creating namespaces within a GKE cluster, and then we use a role-based access control to permit a non-admin user to work with pods in a specific namespace. So in this lab, you will get to learn how to create namespaces for users to control access to cluster resources, and also how to create roles and role bindings to control access within a namespace. So in this lab, we will be using two accounts with username 1 and username 2. So let's start the lab. When you start the lab, you get two usernames here, username 1, username 2, and the password remains same for both of these users, but we need to log into the console as username 1. So let's open this. So now we logged into the console as username 1. So next we will log in again to the console with username 2 but in incognito window. So open link in private mode window. We need to log in with username 2. Copy this. The password remains same. So we had logged into the console with two different accounts. So as username 1, I am in this window. Let's activate Cloud Shell. Here first let's set the project. So you can copy paste this gcloud config set project followed by project ID. So the project ID will get it from this lab. So copy this project ID and paste it here. So now we have updated this property. I am back to this console. Here we logged in as username 2. Here also we need to activate Cloud Shell. So we will use the same project ID. So we had copied this project ID. So we will use the same project ID here as well. Project remains the same, but only we are using two usernames. So now let's go back to lab. So as a username 1, we need to connect to the GKE cluster. So first we need to set the environment variable. So we will be exporting the zone and the cluster name here. So my zone is the environment variable and we are exporting the value here. So the zone is US West 1C and the cluster name is standard cluster 1. So let's copy this. Now it is set. Next we need to configure tab completion for the kubectl command line tool. For that we need to execute this. Next we need to configure access to the cluster for kubectl. So for that we will be executing this command gcloud container clusters get credential, and we are passing this my cluster variable. So which is basically cluster name, and the zone we are passing here. So let's copy this. So when we execute this command, a kubeconfig entry gets generated. So you can see entry got generated for standard cluster 1. After that we have this code in this repository, and that code we are cloning into our Cloud Shell. So copy this, clone this repository onto your terminal. So now we have cloned this repository. So when we do ls, you can find this training data analyst. So next we will create a soft link as a shortcut to this working directory. So ln-s means it's creating a soft link here for this. So let's copy this. So next we need to change to the directory that contains the sample files for this lab. So we are cding to this ak8s. Here we created a soft link, right, as a shortcut to this working directory. So that's why we are passing that name here, ak8s, and inside that rback, and this contains sample files. So let's copy this. So when we do ls here, see this contains YAML file, namespace.yaml, pod.yaml, role.yaml, production pod YAML file, and this is a for username editor binding.yaml file. These are the YAML files which we will be making use in upcoming task. So next we will create a namespace. So we already have this namespace.yaml file. So using this we can create a new namespace called production. So this is the one. You can cat this file. See, inside this YAML file we have defined this kind as namespace and metadata name as production. So it will create a namespace by the name production. So before creating a namespace, let's list the current namespaces in the cluster. So when we execute this kubectl get namespaces, it will list all the available namespace in that cluster. So let's copy this. So you can find this default gkey managed. So all these are namespace. Next, we will execute this command to create a namespace. So we need to execute kubectl create, and the -f is a file name. So we are passing this file my namespace.yaml where we have defined that config to create a namespace. So let's copy this, execute it here. So you should get this message, namespace production created. Again when you execute this kubectl get namespace, now you can see this production namespace being listed and the status is active. Suppose that we can also describe this namespace by executing this command kubectl describe namespace and the namespace name. So let's copy this, execute it here. It is describing this namespace. The name is production and the label is this. Annotations we don't have any, and the status is active. So if you do not specify namespace of a pod, it will use the default namespace. So we already have this mypod.yaml file, which is a manifest file where we have defined this configuration with which it will create a new pod. So let me clear the screen. So let's do ls. This is the pod definition file. So here we have defined the kind as pod and metadata name nginx, label we are labeling this as nginx, and the specification container specification we have specified it, image it should use the nginx, and the container port is 80. So next we will be creating this pod. So we created this production namespace, right? So we will be creating this pod inside this production namespace. So if we don't specify this namespace and if we just run this command, then what it does is it will create a pod in a default namespace. So that's why it is important that we pass this namespace flag if we are creating a pod in a specific namespace. So let's copy this. So here it will kubectl apply -f file name we are passing mypod.yaml file. So it will read the mypod.yaml file and it will create the pod in this namespace. See, pod nginx created. We can also define the namespace in YAML file. So under metadata section, we can mention the namespace and production is the namespace name. So instead of passing it in command line, we can pass it through YAML file as well. So now let's run kubectl get pods. It should list this. So when we execute this kubectl get pods, we are getting no resource found in default namespace because we had created this pod in production namespace. So that's why we need to pass this namespace name when we pass this flag namespace production, it is listing the pod. So Nginx is the pod. You can click on check my progress. So we created a namespace and we also created a pod inside that namespace. In task 2, we will look more into roles and role bindings. Here we will create a sample custom role and then we'll create a role binding that will grant username to the editor role in the production namespace. So you remember we have two usernames here. So as username 1 we had created the pod inside that namespace. Now we will create a custom role which will grant username to the editor role in the production namespace. So we already have this pod reader role.yaml file, and using this we will create this custom role. So here if we do ls, this is the one. So when we cat this file, so this is the manifest file. Here we have defined namespace production and the name for this role. So kind is role and we are creating a custom role by the name pod-reader, and under rules we are defining what all permissions are permitted for this custom role. So under resource we have specified pod, so we will have permission to create pod, get the details of the pod, list the pod and watch the pod. To create a custom role, the creating account should have the permission. So we need to grant username 1 account cluster admin privileges. So for that we need to execute this command kubectl create cluster role binding followed by cluster admin binding. So we are binding the admin privilege for this user. So only if the user is having these privileges, you will be able to create a custom role. Usually cluster administrators will have this option to create a custom role directly without having to bind the role, but for this username one we have to bind this role. So let's copy this. So here we need to replace this user email address with this. So copy this. So now this role binding is complete. Next we will create the role. So here we will be executing command kubectl apply -f followed by this file name. So in this file we have defined the custom role configuration. So let's copy this. So now this is created, pod reader role is created. So we can list this role by executing this command kubectl get roles in namespace production. So let's copy this. See, now you can see this is the custom role. We had created a custom role. Next we need to bind this role to a user. So we have this username to editor binding.yaml file which creates a role binding. Role is used to assign privileges and this role must be bound to a user to perform any operation. So for that we will be doing a role binding now. So we already have this YAML file. So this YAML file creates a role binding by this name username to -editor for this user ID, for the second user ID, and this custom role can create and view pods but it cannot delete them. So let's clear the screen. Let's do ls. So here we can find this username to editor binding.yaml. Let's vi this. So here, so we need to replace this username to email with the actual email address of the username to. So let's go back here, copy this and update it here. Once done, you need to save this. So now this is saved. So you can use vi editor to replace this placeholder username to email with the actual username to email address, or you can also export user to variable. So here you can export the username to like this. Then you can use this command set -i to replace the placeholder in the file with the value of the environment variable. So this way also you can do it, or you can directly use the VI editor to make the changes there. So after this we will test the access. So now we will test whether username 2 can create a pod in the production namespace. So as username 2 we need to check this. So in incognito mode I have logged in as username 2. So let's activate Cloud Shell here. So here let's set the project ID by executing this gcloud config set project. You will get the project ID here. So in Cloud Shell we will export the zone and the cluster. Now we will copy this. We are performing the same as username 2. So whatever commands we ran there in as username 1, we are executing the same. So we are configuring access to the cluster for kubectl. Kube config entry got generated for cluster. Next we will clone this repository. So next we will create a soft link as a shortcut to the working directory by executing this command. So it's all repeat. Next we will change to the directory that contains the sample files. Let's copy this. So now we are inside that. Let's try to get the kubectl get namespace. So as username 2 we are checking the namespaces. We are able to list this namespaces. So next we will try to create a pod. So for that we will execute this command kubectl apply -f followed by this YAML file. We got an error here, error from server forbidden. User, so this user cannot create resource pods in API group in the namespace production. Requires one of the container pods create permission. So we are unable to create this pod in the production namespace as username 2 because we don't have permission. So now we will switch back to username 1 and provided permission. So we will be executing this command kubectl apply -f and we are doing a role binding. So once we create the role binding, this will grant username to the pod reader role. So you remember we created this pod reader custom role which add permission to create pod, to list pod and to watch that pod. So these permissions we added to that custom role. And now we are performing a role binding to this username too. So for that let's copy this, and as username 1 we need to perform this operation. So now the role binding is created. So let's get this role binding details by executing kubectl get role binding. So this role binding we created in production namespace. See now you can see this username to -editor. So we had created that. So now we will try to create again. See now it got created because we created a role binding for this username too. And we can verify the pods by executing this command kubectl get pods followed by the namespace. And as username 2 we are executing this kubectl get pods. So now you can see this production -pod is listed. Next we will try to delete this pod by executing this command kubectl delete pod, and this is the pod name and in the namespace production. So let's copy this and here let me clear the screen. So let's execute it here. Error from server. So this user cannot delete a resource pods in API group in the namespace production requires on off container pods delete permission. So this user doesn't have a required permission to delete the pod. So you remember we have given only create list watch permission for this user and delete operation is not permitted. That's why it's failing for him. So once it is done, you can click on check my progress. This should be complete. In this lab, we saw how to create namespace and how to create a resource. We also saw how to create a custom role and create a role binding for this and provide access to another user to create a pod in that specific namespace. So once you're done with both the tasks, you can click on End Lab. I hope this video was helpful. If you have any questions or feedback, please leave a comment under comment section. Thank you all for watching. See you in the next video.